This is a self-balancing robot that I built with my son about 10 years ago. And I'd always meant to make a video of it back then, but for some reason it took until now to do that. Let's see if it still works. So it basically stands up on its own. You can kind of nudge it, it'll recover. And it's also radio controlled. You can turn on a dime. Go forwards or backwards. See if we can get a figure out. Now this one's a little different than other ones that I've seen in that it actually uses stepper motors rather than DC motors. And now they're not necessarily the best choice, but the whole project started because we had some stepper motors that we wanted to build something with. Ended up building this robot. But then it turned out that the steppers that we had weren't really strong enough, so we had to get some stronger ones. But amazingly, it still works after 10 years. Mostly collecting dust. Okay, let's take a close-up look here. So these are the stepper motors, and again, stepper motors aren't really the ideal choice for this type of project, but really the whole project started because we had some stepper motors that we wanted to experiment with. The cool thing about using steppers is that the control is entirely digital. So basically, this is an Arduino microcontroller here, and it's basically doing everything. Including generating the pulses to control the motors. So let's look at the components here. So these are the steppers. These are the two sensors here. This is a gyroscope, and this is a 2D accelerometer. And those are both connected directly to the Arduino with a little bit of analog filtering in between. These heat sinks along here, these 8 basically driver circuits are just used to adapt the low current output of the Arduino to be able to drive the poles of the motor. So there's 4 poles for each motor, and so there's 8 of these drivers altogether. These are just the load resistors to limit the current through the poles of the motor. This is the radio receiver. It's just a standard 2-channel receiver, and I had to open that up and find the demodulated composite signal, which has the pulse train, so that I could connect that to the Arduino. There's a level adapter circuit here, but basically that's a signal, composite signal, which is going to the Arduino, and then the Arduino is decoding the pulses from the receiver on top of everything else that it's doing as well. That's it. I guess those are all the major components. Yeah, so basically the Arduino is doing all the work. It's reading the gyro and the accelerometer 100 times per second, and then generating pulses of varying width and frequency depending on the required velocity. This is a 2400 milliamp hour, like a 7.2 volt battery pack, and I just wrap the foam around it to protect it because sometimes it falls over. In fact, that's really I guess the main limitation of using stepper motors is that if you exceed, like if it hits a bump or something, and if you exceed the I guess locked rotor force or the hold-in force of the poles, and then it skips a pole, essentially at that point, it loses control because the feedback loop becomes unlocked. The motors can't generate torque anymore. But so there's limits in the software that try to limit the acceleration so that doesn't happen. But if it hits a bump or something, then there's not much you can do, and it'll sometimes fall over. But other than that, it actually works pretty well.